different tasks, different priorities, one shared resource, and one mutex. What happens? Let's have a look. Hi, in this code, what we have are two separate threads and a mutex. Okay, so we have created a mutex here under using OS mutex new, and we have created two threads, LED red thread and LED green thread. Both of them are the same priority. Red is created first, followed by green. Okay, so if you look at both the code over here, we have LED red thread, which will acquire the mutex, control the LED, followed by releasing the mutex. All right, and over here we have again the same thing, LED green thread, acquire the mutex and release the mutex. Okay, now looking at the default behavior, okay, we know that whichever task acquires the mutex first, all right, it will lock the shared resource, and if another task comes in, of course it will have to wait until the current thread releases the mutex. Okay, now what I have done here is, all right, I have created, all right, or I have added the code here that will change the priority of the green thread. Okay, and what is important to note is the LED red thread is the first one to acquire the mutex. All right, but in order to make sure we understand the concept of what happens when a higher priority thread also locks the mutex, what I've done is I have also added a OS delay over here. That means the moment the red thread acquires the mutex, it goes into a delay, which will allow the green thread to run. And the green thread raises its priority level to be higher than the red thread, and then also acquires the mutex. Okay, so now the important thing is what will happen, all right? Because now the green thread has come in and also tried to acquire the mutex, okay, which was acquired earlier by the red thread, but it's now gone into a block state. All right, so in terms of the timing diagram, all right, what we can draw is we can say that the red thread runs first. It does a mutex, okay, acquire. Okay, and after that, what happens is I go into a block state. And once I go into the block state, the green thread is able to run. And what I do is after that, I increase the priority. Okay, so the priority level goes up. So initially, both of them are considered medium priority. Okay, but once I increase the priority, it goes to high. All right, and after I increase the priority, I also do a mutex acquire. Okay, so a higher priority thread has now come in and is now also tried to do a mutex acquire. So what would happen? All right, will the green LED thread run or the red LED thread, or will it wait until the red LED thread releases the mutex? Okay, so let's see this in action now. Okay, so I'm going to build the code over here. Okay, and at the same time, I'm going to bring up the camera. Okay, so let's run the code now. Okay, so when I run the code, you can see that the red LED is the first one to blink, followed by the green LED. Correct? Okay, so let's just confirm the sequence again. Okay, so I'm going to put a breakpoint here. So I'm going to stop the code. Execution, put the breakpoint here for LED green thread and the LED red thread. Okay, and then we're going to run it. Okay, so you can see that the LED red thread is the first one to execute and acquire the mutex. And then following that, the green thread runs. But of course, when the green thread runs, we have already raised the priority. Okay, so after we raise the priority, then we execute the OS mutex acquire. Okay, and then if I run it now, you can see that the red LED thread goes first, followed by the green LED. Okay, so basically what is happening is, even though green LED thread's priority was raised and it executed the mutex acquire, it still cannot carry on because it was already acquired by the red LED thread. Okay, so it has to wait until the red LED thread releases the mutex, and then only it can carry on running. Okay, so that basically gives us a good idea of how the mutex works even with threads of different priority. So the priority doesn't matter as long as a single thread has already acquired a mutex. Okay, even if high priority thread comes in and tries to lock the mutex, it will still have to go into a block state until the red LED or the lower priority thread releases the mutex. Then only the higher priority thread can carry on running. Okay, so that is basically what is happening. Okay, so again, please check my other video where I have given the explanation for the semaphore behavior. Okay, for the semaphore behavior, it is a bit different, where the higher priority task that is waiting for a semaphore will always be the first in the queue to get the semaphore. Okay, so it's a bit different. Okay, when you look at it in terms of behavior for the mutex as well as the semaphore. Okay, so you do check out that video. Okay, the link is up here in the video. Thank you. Bye.